We're going to concentrate in section 2.4 on Venn diagrams and verification of equality of sets. To verify that set statements are equal for any two sets selected, we're going to use a deductive reasoning with Venn diagrams. So we're going to use some general regions. We're not going to have exact elements, but we're going to look at some general examples, and then we're going to try to prove that if they are true for the general examples, then they would always also be equal when we talk about some specific sets. So the way that we do that is, if both statements represent the same regions of the Venn diagram, then the statements are true for all sets A and B. So in our first example, we're going to look at a Venn diagram that has represented a set A and a set B. And when we draw that Venn diagram, we've now divided the universal set into 4 regions. So as we go through and try to determine if these two set statements are represented by the exact same region, we need to be organized and set up a nice chart so that we can determine that. So to better organize our thoughts, we want to first find the regions that are represented by this set statement. So I'm going to go through first, and let's take this piece by piece. We want to work within the parentheses first. So set A contains what regions on my Venn diagram? And that would be both 1 and 2. Set B is represented by region 2 and region 3. And then the union of A and B, we would list every region that's included in either A or B. So that would be region 1, region 2, and region 3. In this statement, however, we need the complement of that. So A union B, the complement would be everything in the universal set that is not contained in A union B, which is only leaving us with region 4. So now let's see if A complement intersect B complement is represented by that same region. So first, A complement. Now we've already discovered that A was regions 1 and 2. So A complement would be represented by regions 3 and 4. So then the intersection of those two sets, we would intersect A complement and B complement. What do they have in common? Looks like the only region that those have in common would be region 4. So we can say that if that's true for the general regions, then no matter what I have in my set A and B, this statement is going to be true no matter what set A and B are. So those two sets are equal. So the solution would be that both statements are represented by the same region 4. So the complement of the union of A and B is equal to the intersection of A complement and B complement for all sets A and B. Now let's look at a more complicated example that would require us to draw 3 sets. On a Venn diagram, when we represent 3 sets, we end up with 8 regions. So we're going to set it up very similar to the way that we did our Venn diagram with 2 sets. So let's first look for what region or regions are represented by this set statement. We need to find first of all what regions are represented by set A. Set A contains or is represented by regions 1, 2, 4, and 5. Let me highlight that for a second. So set A is represented by regions 1, 2, 4, and 5. Set B is represented by regions 2, 3, 5, and 6. So A union B would be represented, and here I'm looking at my chart. We want to include every region that was included in A as well as B. So region 1, 2, 3, 4, 5, and 6. And then what would also help us with this statement, if we want to find C complement, for me that's easier to first find the regions that are in C and then find the complement of that. So the regions that represent set C would be 4, 5, 6, 7, which would then make C complement everything else that's in the universe that was not in set C. That would be 1, 2, 3, and then don't forget 8. And then now I want to find the intersection between A union B and C complement. So the regions that those two sets would have in common would be 1, 2, 3, and that would be all. So now let's move on to the second set statement. If I want to find first of all A complement, now we've already listed A, so A complement would be everything remaining in that universe, which would be 3, 4 is already in A, 5 is already in A. We would also need 6, 7, and 8. C complement we've already listed as 1, 2, 3, and 8. So the intersection between those two sets, what they have in common, would be region 3 and region 8. And next I'm going to write B again. We could just look on the other chart, but B included regions 2, 3, 5, and 6. And so finally this statement, the intersection of A complement and C complement, union B. So we want to look at all of the sets that are included in both of those statements, which would be, all the regions. That would include 2, 3, 5, 6, and 8. So we can see that the general regions are not the same. So those two statements are not represented by the same regions in our general Venn diagram. So we would say that those two sets are not equal sets.